Hello students, welcome to this module number 5. We are going to discuss about the concept of ideal gas. In this lecture video, you are able to understand ideal gas mixture and Dalton's law of partial pressure. So let us understand what you mean by ideal gas. So already you have studied in the basic level of engineering what is meant by ideal gas. So this ideal gas is an imaginary gas having no forces on intermolecular interactions, so that the behavior of the molecule is not influenced by a presence of other molecules. And also it is obeys the law of PV is equal to RT at all pressures and temperatures. So where P, V and T are corresponding pressure, volume and temperature, and R is the gas constant. This relation we call it as ideal gas equation of state, and it is obeys the gas laws like Boyle's law, Charles law, Gay-Lussac law, and Avogadro's law. So let us understand what is meant by Boyle's law. So already you know that in the relation of this volume and pressure, one scientist, that is Boyle, is proposed a law, that is the relationship between the volume and pressure of a gas of fixed amount at a constant temperature. So what he observed, that the volume of a given mass of a gas is inversely proportional to its pressure at a constant temperature. Okay, and he published in the year 1662, so that the state that at a constant temperature the product of pressure and volume of a given mass of an ideal gas in an enclosed system is always constant. Okay, so it can be very experimentally, but using this pressure of even though if you can he is also found in experimentally using a pressure gauge and a variable volume container. So it can also be derived from the kinetic theory of gases. So if the container with a fixed number of molecules inside and it reduced in volume, the more molecules will strike and a given area of sides of the container per unit time. So what it gives relation, the volume of given mass is inversely proportional to pressure. So when the temperature is get constant, so that is V is inversely proportional to its pressure. So meaning is that, so volume is inversely proportional to pressure, so at a constant temperature, or vice versa. Even the pressure is inversely proportional to volume, that is P is inversely proportional to 1 by V. So this is the equation. If you take this proportionality, remove the proportionality, that relation becomes PV is equal to T. So that is the T is a constant. Or if you take the two states, that is state 1 and state 2, then this equation becomes P1 V1 is equals to P2 V2. Okay. Similarly, for the Charles law, so he is also one of the scientists. He proposed that is the volume and temperature relations at constant pressure. So as volume increases, temperature also increases at constant pressure. So this will we call it as a Charles law, and he is proposed in the year 1787 itself. Okay, so what it says, that the statement of this Charles law is volume of a given mass at a constant pressure is directly proportional to its temperature. So mathematically we can write it as V is directly proportional to T, or V by T is equals to constant. If you take two states, the state 1 and state 2, then it becomes the V1 by T1 is equal to V2 by T2. And similarly, for the Gay-Lussac law, that the scientist also he proposed a law. That is pressure. Stated that the given mass and constant volume of an ideal gas, the pressure exerted on the sides of the its container is directly proportional to its absolute temperature. So that is P is directly proportional to T. So this is then what we call it as Gay-Lussac law. So once you understand this ideal gas state, so and it is also obeys the all gas law, then the gas becomes an ideal gas. Okay, so let us understand what we mean by ideal gas mixture. Suppose if you take a mixture of perfect gas or ideal gas, for different types, carbon dioxide, nitrogen, hydrogen, like that, ABC. So it exists in equilibrium at pressure and occupying a volume of V at temperature T. So each constant occupies the same the volume of entire mixture, and it occupies, and it also, each constant is at same temperature of the mixture. This is what we call as absolute or perfect gas mixture. Okay, so in this understand what will be the some terminology involved in this gas mixtures. So we should understand what is mean by mass fraction. Okay, suppose mass fraction is nothing but is the constant of gas is the ratio of the mass of the constant gas to its total mass of the mixture of perfect gas. Suppose if you take in a container or in the mixture of gas is carbon dioxide, nitrogen, hydrogen is there. So I want to calculate the mass fraction. Okay, so what we have to do? So I have to take the mass of the individual constituents to its total mass of the mixture. That is what mass fraction. So this will be always less than 1. The mass fraction should be always less than 1. Suppose if you take A, B, C is the three different gases and it is mixture, and then you want to calculate each mass fraction, then it becomes mass fraction of A plus mass fraction of B plus mass fraction of C. That if you add it, you will get, it should be 1. And let us come to this what is mean by mole. So already you know that a mole is a substance that has a mass numerically equal to the weight of the substance. Suppose if you want to know about what is the mole fraction, means the total number of moles of the mixture is equals to the sum of the moles of the individual gases. This is about the mole fraction. So next concept is what is meant by Gibbs law of Dalton pressure. It is related to the pressure. First you remember that it is related to the pressure. So the total pressure of a mixture of perfect gas is equal to the sum of a partial pressure of the constant of the gas. Okay, so if each component is exits separately at the same temperature, the volume of the mixture. Okay, so if this component we call it as P, so that is what sum of all the pressures. P is equal to P1 plus P2 plus P3. So how many gases are there? All pressures we are going to add up. Okay, so next, suppose for example, consider three gases. With an example I am explaining. So the gases like A, B, C. Okay, and gas at various pressure, temperature, pressure at, okay, A, and mass of the A, and moles of the A. So like that, A, B, C gas you take. So this represents what Dalton's of partial pressure. That is, if you have to add all these, and it should value should be 1. That is PA plus PB plus PC. Okay, so I hope you understood of this concept of uh, ideal gas and what is Dalton's law of partial pressure. So once you understand the concept, you must able to know how to basic equation is going to be derived, and how it is going to be calculate the various parameters like pressure, volume, temperature. Okay, like that. So let us will move on to the next video of the concept that is coming Avogadro's law, how it is going to be differ from the partial pressure. Okay, so that we will discuss in the next video. Thank you.